Okay, so this is the key to worksheet section 9.3 part B. All right, um, so these are linear equations, and remember, you got to make sure that as you go through the process, everything you have is, every statement you make is mathematically correct. You can't have any errors, so otherwise you will not get full credit. All right, so if you notice this one in particular, this linear equation, I have parentheses involved, so let's go ahead and use the distributive property. And so I get 6x minus 7 equal, and then over here I get 3 times 2x is 6x, and then 3 times 3 is 9, a positive 9. You guys say plus 9. And then let's just rewrite everything else over. Now remember, this is number 2 for this problem, so don't get that confused. All right, now once you combine like terms, usually, not always, once you use distributive property, usually what's going to happen is that you will probably be able to combine like terms. And I can here. Now on the left side, there are no terms that are alike, but on the right side there are. So let's go ahead and rewrite the left side. It helps if you do one thing at a time to keep your thought processes correct. All right, a 6x and a negative 7x is a negative x. Now my constants, 9 subtract 2 is a positive 7, so you got to write negative x plus 7. All right, now the next step is to bring all the variables to one side, constants to the other. So this is a negative x. I'm going to go ahead and add x to both sides. So again, I'm using the addition property of equality. So in each case, in all of these, you're going to be using the addition property of equality. So remember, the addition property of equality says that if you add a term on one side, you got to add it to the other side as well. So if I'm adding x to this side, I've got to add x to the other side. So what I do to one side, I do to the other. Now, usually when you use the addition property of equality, the next step is to combine like terms. So 6x plus x is 7x minus 7 equal, and then a negative x plus x is 0, and that's what you wanted. So 0 plus 7 is 7. Okay, so notice that you wanted to solve this equation. There's no way you could have looked at this and determined what the solution is. So you're going through these processes, you're going through a process to determine what the solution is. So using some properties. So one of the properties I used was distributive property. The other property was the addition property of equality. All right, now in solving a linear equation, you want to bring all the variables one side, constants to the other. So that's the process I'm going through. So I brought the variables one side, now I'm going to bring the constants to the other side. So right now I'm subtracting 7. Subtracting 7 from both sides is not going to help, because a negative 7 and negative 7 is a negative 14. I still don't have the variable term by itself. So you got to add 7 to both sides. But notice what I just did. And again, I'm using the addition property of equality. I added 7 to the left. I've got to add 7 to the right. You got to show that. And then when I combine like terms, a negative 7 and a positive 7 is 0. And so 7x and 0 is 7x equal 7 plus 7 is 14. Now, at this point, you can look at this and say 7 times 2 is 14 and say the solution is 2. But what we want you to do is actually go a little bit further and actually get the variable x by itself, even though you can see this and say the solution is 2. So notice as we went through here, there's no way you can determine that this solution was 2. So then you're doing some mathematical processes to get to the point where you can determine the solution. So the solution of this is the same as the solution of this, is the same as the solution of this, is the same as the solution of this, and so on. So all these equations are equivalent. And then you get to the point where you have this equation now, which is equivalent to all of these others, and you can see now that the solution of this equation is 2, so the solution of that equation is 2, solution of that equation is 2, and so on. But again, you want to get the variable x by itself. So right now I'm multiplying by 7. In order to get the coefficient of 1, see that coefficient here is 1. In order to get the coefficient of 1, I got to divide by 7. But if I do one side, I have to do the other. You got to show that, otherwise it's not mathematically correct. So basically, if you say this, if you say 7x equal 14, and then all you do is this, and then say x equal 2, that's not correct. Mathematically, that's not correct. Because when you write this, you're saying 7 divided by 7 is 1, 1 times x is x, and you're saying x is 14, and that's not true. So you got to be careful. All right. Now, so I get 14 divided by 7 is 2. So that's your solution. All right, over here, we're going to do the distributive property again, except this time I got to use it twice. So I get 4 times x is 4x, 4 times a negative 3 is a negative 12, and then minus 8, equal, and then 8x, a negative 3 times 2 is a negative 6, and negative 3 times a positive x is a negative 3x. Right, so that's what you get. The next step is to combine like terms. So on this side, I can combine these constants right here. A negative 12 and a negative 8 is a negative 20. So I get 4x minus 20 equal, and over here I can combine these variable terms. 8x and a negative 3x is a positive 5x, and then minus 6. And now that looks like this part here. So let's go ahead and use the addition property of equality. And by the way, when I did this, when I divided both sides by 7, I was actually using the multiplication property of equality. So remember the multiplication property of equality. All right. So basically multiplication property of equality, and usually we use this last. Not always, but in this, what we're doing here, it ends up being last. The last thing we do. So basically multiplication property of equality says if I multiply both sides if I multiply one side of an equation by a factor, I've got to do the other side. If I divide, I got to do on one side, I got to do the other side. Okay, over here, let's go ahead and bring the variable terms to the left, just to show you what's going to happen. So if I subtract 5x on both sides, and see that's what you have to do though in this case, you're not going to add because 5x plus 5x is 10x. All right, I want this to be a 0. In order to get that to be a 0, I've got to subtract 5x. But what I do to one side, I have to do the other. So you got to show that to be mathematically correct. Now, remember, I'm using the addition property of equality. That's what I just did. So I subtracted 5x on the left, I subtract from the right, I subtract 5x from the left. Now the next step is to combine like terms. 4x and a negative 5x is a negative x, which means the same thing as negative 1x. Keep that in mind. And so I get negative x minus 20 equal negative 6. Now, the next step, remember, you bring all the variables to one side, constant to the other. So let's bring the constant to the right side. So right now I'm subtracting 20. The opposite is to add 20. And then combine like terms. So again, I'm using the addition property of equality. Now I'm combining like terms. When I combine like terms, I get negative x equal a negative 6 plus 20 is a positive 14. All right, now remember, I'm trying to get x by itself. I don't have x by itself. That's a negative 1x here. So it helps, though, in this case, actually write negative 1x so you can see what to do. So remember, I want this to be a positive 1 when I get x by itself. So right now, I'm multiplying by negative 1. The opposite is to divide by negative 1, just like this. And so I get negative 1 divided by negative 1 is 1. 1 times x is x. And then 14 divided by negative 1 is a negative 14. Now, one of the things I want to remind some of you is this. When I did this right here, because this is an error I keep seeing, when I had this equation, 7x equal 14, what some of you are doing is you're dividing both sides by 7x. Don't do that because you're trying to get x by itself. Always divide by the coefficient, because when you do this, you're saying x equal 2, which is the correct solution, but that's not what this says. This says that 7x divided by 7x is 1, and this says 7 divided by 7 is 1, 7 divided into 14 is 2, and basically what you just wrote, when you do this, what you just wrote was you said 1 equals 2 over x. That's what you just did. So be careful. You never divide by the variable. Always divide by the coefficient. All right. So you got to be careful. Some of you do that, and you get points taken away because in your mind you're not thinking about this correctly. You have some misconception here when you do it that way. Okay. Now, so I get negative 14 as the solution. Now in number 3, we end up with we see that we have fractions here, fractions involved. And so the best way to do these, and there are multiple ways, but the best way to do this to make it efficient on yourself is to multiply, is to get rid of the fractions. Since I have an equation, is to get rid of the fractions. So we're going to multiply both sides by the LCD. And always use the least common denominator. You can use a common factor like over here, the least common denominator of 5 and 3 is 15. I could use 30 if I want to. I can use 45 if I want to. But always use the least. It makes things easy on yourself. So in this case, the least common denominator is 15. Because I have a 5, a 3, and this 2 is really 2 over 1. So 5, 3, and 1. See, if you look at this, I have two terms. I'm sorry, three terms altogether. 1, 2, 3. And so if I look at all the denominators, 5, 3, and this is a 1 right here, 2 over 1. The smallest number that 5, 3, and 1 go into is 15. Now, basically what you're doing is you're going to multiply both sides by 15. Okay, so now I'm using the multiplication property of equality first. All right, so I'm using the multiplication property of equality first here. Now, you got to be careful because what some of you are doing is just saying 15 times 3/5 x minus a third equals 2 times 15. Now, mathematically, that's not correct because the way you've written it was you're saying that what you mathematically wrote was that you're saying 15 is only being multiplied by this term. But it's got to be multiplied by this term as well. So you got to put that in parentheses. So make sure that everything you write is mathematically correct. All right, now we're going to distribute. So I get 15 times 3/5 x, and then minus 15 minus a third times 15. So 15 times a third. So 15 times a third. So minus 15 times a third. Equal, and then 2 times 15 is 30. I'm going to just go ahead and put a 30 here. All right, now remember the whole purpose of multiplying by the LCD is to get these denominators to be ones. So if I multiply by the LCD correctly, I should be able to reduce. 5 and a 5 is 1, 5 and a 15 is 3, and then 3 times 3x is 9x. Minus, again, the whole purpose of multiplying by the LCD is to get this to be a 1. 3 to 3 is 1, so when I reduce, 3 into 3 is 1, 3 to 15 is 5, and 5 times 1 is 5, equal 30. All right, once you get to that point, it looks like these problems here. So it makes things a lot easier. Okay, now I'm going to add 5 to both sides, combine like terms. So now I'm using the addition property of equality. So I get 9x equal 35. And again, I'm trying to get x by itself. So I want to find the solution to this original problem, to this original equation. So let me go ahead and rewrite this over. 9x equal 35. So remember, I want a coefficient of 1. So right now, I'm going to use the multiplication property of equality. So in order to get a coefficient of 1, I'm going to go ahead and divide both sides by 9. And again, remember, you got to do it here and here. Not just here as well to be mathematically correct. 9 divided by 9 is 1. 1 times x is x, so I get 35 over 9 as your solution. Or if you want to change it to mixed numbers, see this is improper, so remember how to change this to mixed numbers. Say 9 to 35. 9 to 35 will be, not 4, it will be 3. So that's 27. And then that will be 8. So you get 3 and 8/9. Okay, over here, if you look at this, if you look at this equation, think about how many terms you have. You have 1, 2, 3, 4. So there are 4 terms. Let's look at the denominators. You see I have fractions, so let's go ahead and multiply by the LCD. I have 3, this is 3 over 1, so I get 3, 1, 6, and 1. So the smallest number that 3, 1, 6, and 1 will go into, the smallest factor is 6. So I multiply both sides by 6. So the LCD here is 6. Okay, so notice I'm going to go ahead and rewrite the equation over. I'm going to leave some space here. And let's talk about this. So remember, I got to multiply by 6, and I got to multiply by 6. Now, the way I've written it is not correct. And this is what some of you are doing. And mathematically, it's not correct. You will probably lose points for this. So the way I've written it is you're saying 6 times x over 3 plus 3. So the only way the only term that's being multiplied by 6 is x over 3, which is supposed to be this as well. So put that in parentheses, just like this. Now let's go ahead and distribute. So I get 6 times x divided by 3 plus 6 times 3. Now be careful, you got to say 6 times 3. Don't say, some of you are doing this, you're saying 6, 3. mathematically, that looks like 63, the number 63. If you mean this to be multiplication, you better say 6 times 3, like that. All right. Equal, and then this is 6 times x over 6 minus 6 times 2. Notice the multiplication symbol. If you don't have the multiplication symbol, that looks like a 62, and that's not mathematically correct. All right, now remember, the whole purpose of multiplying by the LCD is to get this denominator to be a 1. So I'm going to reduce. 3 into 3 is 1, 3 into 6 is 2, and then 2 times x is 2x. Plus 6 times 3 is 18, equal, let's reduce here. 6 into 6 is 1, 6 into 6 is 1, 1 times x is x, minus, and then 6 times 2 is 12. And now I've cleared the fraction, so that makes finding the solution to this a lot easier. So let's bring the variables to one side. So I'm going to have them subtract x from both sides. So I'm using the addition property equality. Now I'm going to combine like terms. 2x minus x is x, plus 18 equal, that's 0. Minus 12 is negative 12. And then to get x by itself, now addition is easy because the coefficient is already a 1. So I'm going to subtract 18 from both sides. Then combine like terms, so I get x to be a negative 30. And that's your solution. All right, so that's the key to worksheet part B.